Alrighty, let us begin. We finished 2021 Tech Active last time. 2020, let's go. So I'll put those in the chat. The solutions to these I made a little bit ago, so they're not quite as refined. I will fix that so they are looking like the rest of them, the same level of quality. Yeah, there's obviously work to be done with those. They'll certainly explain how to do it, but they could look a little nicer. Anyway, you got both of those. We're going to skip the first questions because they are always the same. Product rule and then chain rule and sub in an x value. It's always some sort of diff thing. So we shall begin with question 2. Probability. Contrasting the differences between oil changes and air filter changes. We're told the probability of an oil change, probability of an air filter change, and the probability of requiring both. We want the probability of an air filter change without an oil change. That's what we're targeting. So yeah, either have a look at the screen share or in the provided exam solutions or exam doc, one of those. Let's crack on.
Is it 1 on 10?
1 on 10. Let's find out. Let me double check. 1 on 10. Sure is. Yeah. How'd you go about getting 1 on 10?
I just sort of thought of it as a Venn diagram.
Yeah, Venn diagram. Yep, that'll do it. The provided solutions here isn't quite a Venn diagram, but Venn diagrams and Carnot tables are the same thing. They're just different ways of presenting the same information. You probably did some similar math to the effect of, well, we had 3 out of 20 for total, 1 out of 20 for the intersection, and so the separation between them should be a 1 out of 10. Is that more or less how that went for you?
Yeah.
Sweet. Here's what I believe is the exact same question, or at least a very similar question, but now probabilities are not numbers, but they are letters instead. You've still got oil change, you've still got air filter, and you've still got both. This time you're given the target probability of air filter change without oil. So I believe that's the same thing here, air filter without oil. Still the same target thing you're looking for, but you're told what the probability is. We're then going to rearrange that to get m in terms of n. It'll overall be the same sort of steps, but then you'll expand on it. whether you use a Venn diagram or a probability table, you're still basically doing the same sort of things. Where previously we had 1 on 23 on 20, 17 on 20, you can now do the equivalent in terms of the M and N things that you were given.
Chris, are we meant to get like a sort of like an equation?
Yeah, so
And
determining
then,
M in terms of N means you have M on one side of the equation and then only constants or N on the other side of the equation.
okay, I got m is equal to 19 n minus 20.
That'll be good. Yeah, that sounds good to me. So yeah, this way I've done again a probability table approach. These two have to add up to give this one, so you just do this minus that to get the thing. We know that has to equal 0.05, and so all we're going to do is map our way through it. Just cancel out the fraction, expand. Well, I guess in this case I've divided by 0.05, got the m on its own, and then just sort of, well, not much else to be said there. Convert the decimal to fraction, perhaps. Usually fractions are a bit nicer to work with than decimals. And then, yeah, just a bit of algebra. Nice. That was a short couple of questions. Fair enough. All right, question 3, tan graph. Fully unknown tan with a and x. We have 2 points on the graph. We're told it's continuous from -1 to 1. So, sure, why not? Find the value of a and the value of b. Yeah, just solve for a and b. There's some restrictions on it. A being positive should make a decent amount of sense given the shape of the tan graph. B being between 0 and 1. You could probably even guess what direction. Oh, maybe not. It's a bit harder to guess that one. You've got two unknowns, A and B. Ideally, when you have two unknowns, you need two equations to solve those two unknowns. There's definitely enough information in here to create two equations. Might get a little bit trickier because you're working with circular functions as opposed to polynomials, but it's still definitely achievable. Especially the points that you're given that help you create the equations. Those are tan exact values. Makes it a lot easier to work with. So step one is definitely going to be to sub in those 2 points. That'll get you your two equations. If you're looking at my solutions, keep in mind I wrote those back when I assume people wouldn't memorize tan values. And so there's a lot more complications to convert to sine and cos and then work from it from there. If you just know your tan value, there's a lot less work that goes into solving this one. Granted, you do have quite a bit of space if you needed to do that in the real thing.
Chris, could you show which like how like sorry, like what equation we want to set up in this?
Yeah, okay. Well, the equations are going to come from the points. So you have your y equals tan ax plus b. Shove in those 2 points. These are going to be your 2 equations.
Right.
Did you have those, or did you want to see where to go from here?
No, I had these ones. I just want to see what to do next.
What to do next? Cool.
Yeah.
Well,
I would
how
assume it's something to do with the exact values of tan.
it certainly does, yeah. So you've got tan equals -1 and you've got tan equals √3. Do you remember your tan exact value and their related angles?
Root 3 is pi on 3,
Yep.
and -1 is probably like negative pi on 4.
-pi/4, yeah. Those should be good. Yeah. So -pi/4 is therefore going to be -a plus b, and pi on 3 is going to be a plus b, right? Because whatever you shove in the brackets of the tan should give you those things.
Alright.
Now, one of the challenges you'll have with that is b is bounded between 0 and 1. So because there's technically infinite solutions here, you might run into a bit of a challenge where if you pick the quote wrong one, you might not get a value of b between 0 and 1. You typically default to going anti-clockwise around the unit circle and picking the first thing. That's how tan inverse basically works. So rather than picking -pi/4 here, you'd probably be safer for 3 pi on 4. Let me see, is that what we ended up doing? Pi on 3 for the first one. Pi on... Why do I write pi on 4? I wrote pi on 4, but it should have been -pi/4. Yeah, okay, never mind. I guess -pi/4 would have worked out anyway. More or less. You typically default to around the unit circle anti-clockwise, but I guess in this case -pi/4 actually does work out perfectly fine. Maybe both work out. Hmm. Anyway, that's the overall approach there. Maybe try with 3 pi on 4. See if you do get a different b value that's out of range. It's even there, -pi/4, and I put positive there. Definitely needs a refresher. I'm trying to think if there's a reason why you wouldn't go 3 pi on 4.
We got like when I used negative pi on 4, I got
Hmm.
uh pi on 24 for B, so it's between 0
Yeah.
and 1. Yeah.
No, it is good. It is good. Yeah.
Yeah.
Picking -pi/4 was the correct way of doing it. I'm just trying to think about why, or if you could know ahead of time why not to pick 3 pi on 4 as your value. Because both technically work. Or at least both like are valid solutions for the tan. But for domain wise, I guess maybe you just got to get lucky. I'm not really seeing any way that you could ahead of time know which way to go. But yeah, those are going to be the values that you work with. Yeah. Cool. Oh yeah, question 4. We've seen a couple of these before. Just solving a log. Like these are really nice for everyone because it's like, oh yes, 3 marks and it's just log law stuff. Awesome. Love it.
Are we going to be using division rule in this one?
Yeah, I would be going through and doing that. Um, it's not technically the only way to do it. You could, for instance, convert everything into a log, get it down to where you have one on one side, one on the other, and then you just compare the brackets. That also works, but just going straight division rule, just don't forget you got to chuck this 2 in there first before you do your division rule. Um, Straight division rule is what I wrote in the answers, but there is a lot of ways you could do it. Yeah. In fact, I'll just have a bit of a play around on the handwritten bit, do it in a different way just for the sake of it. So yeah, there's a fair few ways you could go about that. Both of them are going to get you where you want to go. Let me know when you're looking to continue.
I got x's.
I think you
Oh
might have
yeah.
muted just then.
No, I was about to say x is equal to -7 and -1, but now
Yeah.
I see that if you put -7, it's going to break the log, so
Yeah, that's the final trick in
-1.
there, which is yes, the quadratic is valid for -7 and -1, but you chuck in a -7 into log 2 x plus 5 and shit breaks. Um, Probably the most natural way to do that was again, like you said, the quotient thing, the division law. So you just take the 2 logs you already have, put the square through, and then do the division, and then convert to exponential. That's what I'm showing on the screen share. That also gets you to the same quadratic. The way I've shown in the handwritten is that you can actually convert your 1 into log 2 2, and then combine the 2 logs via products rather than quotient, and compare brackets afterwards. They look like they take about the same length. I know my solutions in here are excessively simplified in the sense that I do very small steps in each of them, so I probably took bigger steps all in one on my written answers just here. So it's a bit harder to compare, but they'd be very similar in length. Okay, back to probability. In a randomly selected group of 4 people, what is the probability that 3 or more have the gene? Even without reading any of the question, you kind of already get hints as to, well, the background information, I guess. You kind of already get hints as to what's likely to be the case. Just keywords like 3 or more. Talking about people. These are little hints that you can derive without needing to spend too much time understanding the background of the information. Probability of the gene, 3 out of 5. Gene is independent. Group of 4 people. These are all leading to one specific kind of probability type. Once you're able to identify what probability type it is, figuring out how to create a probability equation becomes quite easy, especially considering it'll be on the formula sheet. Just remember that it's 3 or more.
Is the probability of that 27 on 125?
27 on 125 is a bit small. How'd you go about it?
I sort of thought of it as like, so if 3 people were to have it, then it would be 3 on 5 to the power of 3 times 2 on 5, because that's the complement of, that's
Yeah,
a probability of someone not having it.
sure.
And then the other case is all 4 people having the gene.
Mhm.
So I just added 3 and 5 to the power of 4.
There's only one thing that's missing a little bit from there, and that's the combination element to what you suggested. So yes, you want to do 3/5 power of 3 and then 2/5, but you got a group size of 4. It can be any 3 of those people. When it's 4, sure, it's just got to be 4 is 4, right? It's just all of them. But when you can pick a number from a group, you've got to then consider the ways in which that number could be picked. And so if you're going to do it that way, then make sure you're keeping the counting method stuff front of mind for discrete stuff. The alternative is to just remember binomial, right? If you can identify, oh, yep, independence, 2 outcomes, either has the gene or doesn't have the gene, then knowing it's Bernoulli sequence means you don't even have to think really hard about it. You just got to figure out what your p-value is. Apparently I put a 3 in there. Nice. Instead of just keeping it as the equation. Anyway, you just do a couple of Bernoulli sequences, and then those simplify out. This is, again, needlessly excessive simplification. You could probably just do 3/5 to the power of 3. You don't have to go and expand this out and then combine them in one at a time. This is ridiculous. You just do 3 cubed and then 5 cubed and then call it a day for both of those. Um, they all have denominator 5, so there's no real complications around your 620, your denominator having to change. You get up to 625 pretty quick. This is not nearly as, quote, rude as I claim it to be. So yeah, basically just chuck a multiplier of 4 on your previous, this section of the answer, and you would have had it. Alright, still a group of 4. This time it's exactly 2, given at least 1. So probability x equals 2, given x greater than or equal to 1. At least 1. Now, yet it also says express it in a particular form. You pretty much don't have to worry about that until after you've done the logic required to create your probability. Though, to be fair, getting it to look like that form, challenging. I'm also going to work on it in the background and see if I can get it to a better stage than I had in my answers. Let's see how bad I was back then. Okay, so anyone's still stuck. Keyword given that. Exactly 2 people given at least one person. That's a conditional probability, which means you want to find the intersection of those 2 things. That's your numerator. And then you want to divide that by the conditional, which is, in this case, at least 1. So x greater than or equal to 1. Both of those are Bernoulli sequence things that you could solve. And then, yeah, the challenge is then going to be a bit of rearranging. Anyone making reasonable progress to get it to look like that? I'm also playing with it, but it's taking some time, I'll say. I'm curious if anyone's making better progress. Yeah, I think I might show this one instead of the solutions I have on top. Oh, in the dock. I think this is getting to it a bit faster. Okay, cool. Let's try this. Not quite done yet, by the way, but getting there. So first things first, the intersection of those two things is going to be just probability x equals 2. All right, you've got x equals 2 given greater than or equal to 1. The intersection is going to be x equals 2. Then on the bottom, at least 1 being having the gene, that's x greater than or equal to 1. The opposite of that, to make the Bernoulli sequence significantly easier, is to do 1 minus x equals 0. And from there you play with it. So the top there is going to be your x equals 2, the bottom there is going to be 1 minus x equals 0. I kind of know whenever I'm dealing with x equals n or x equals 0, all the other stuff disappears and you've just got the repetition of either 4 fails or 4 successes. In this case, it's obviously 4 fails for x equals 0. Then from there, do a bit of cancelling. So expanding out those factorials. I kind of missed the mark. I was meant to cancel a 2. That's what we're going to simplify down to 6. And then we play a bit. So I'm realizing, okay, on top, I want something cubed. On bottom, I want 2 things that are power of 4 subtracting each other. That's what it says to do. Now, more specifically, it tells me they should be integers, z positive integers. And so, yep, I've got fractions that are power of 4 and power of 2, or close to being power of 3. I need to get rid of these fractions. And so I'm thinking, okay, cool. First things first, simplify things down, combine. So I've got 2 things that are raised to the same power. I can shove those into each other, no problem at all. Because the powers are distributed. Then what I've done is I've got this power of 1, this integer of 1, which I could put a power of 4 in there, but because I'm trying to take factors of fractions out, I'm going to rewrite that as a fraction, just so I can work with it a little bit easier. And then this is where I basically ended up, which was, okay, now I'm going to start taking out the denominators of each of these fraction stacks. So 25 can come out as 1 over 25 squared. That's still on the top. And then these both have a common denominator of 5 power of 4, so I can take that out as well. And what I'm seeing is I've got, oh shit, look at that. I got something power of 4 minus something power of 4. And this is going to become a power of 3 thing. And so, you're going to have 6 cubed. That's chill. You're going to have 5 to the 4 minus 2 to the 4. That's cool. Then we just got to make sure, hey, do these things actually cancel out? And all you got to do is realize, okay, well, 5 to the power of 4 is just 5 squared squared. So I could rewrite this as 1 over 25 squared. That is the same as that. Same thing on top and bottom. They're going to cancel out. And that gets me to what I want. So let's see, how many lines of working was that compared to what I've got in there? 1, 2, 3, 4, 5, 6, 7-ish. Versus, what did I have here? 1, call it here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it's going all over the place. Cool. So again, I will rewrite these. You do in fact get to the same answer. I guess the message there is the speed at which you're able to get to an answer is going to be very, very based on how strong your algebra is. And so you can kind of get a little bit of a perspective here as to how you can grow over time. Like this is me writing solutions at the very beginning of my career as a tutor versus now I can get there significantly faster. That's what practice looks like. Yeah, these are the kinds of unlocks that you can have if you continuously spend time practicing. Was there anything in there that I should clarify further? Maybe about like the handwritten versions, because that was a bit messy, the other one. Any of that not making too much sense? Just little tactics in there like converting integers into fractions if you know you've got to get rid of. In fact, that might be a bit counterintuitive. Right? The idea that you want to get rid of these fractions, and so to do that, you create a fraction. It's not necessarily overly intuitive. But yeah, these are just some tools you can use to rearrange equations to fit a particular form. Good news is none of that here. Question 6. Domain and rule of F inverse. Very standard question. Finding inverses, always done by first swapping the x and y and then rearranging for y. Just don't forget to relabel it as F inverse, don't just leave it as y. 2x squared is correct, yep, well done. That will be the function, the rule of F inverse. That'll get you 1 mark. There's another section in there.
Is the domain going to be 0 to infinity?
Y 0 to infinity.
I think that was the range of the original.
Yeah, so any square root over its maximal domain is going to have a range that's also 0 to infinity. Have a look again at the
Oh wait, okay, my bad, I see.
yeah, yeah,
Let's see. Which one to one? It's just gonna be 0 to 1 then?
0 to 1. That's a bit better. But yeah, you're totally right in the sense that if this was maximized, then yeah, you'd have a range of 0 to infinity on that as well. But yeah, obviously that came with a restriction on the domain there. So yeah, for the recording, just subbing in 0 and 2 into both of those will get you your possible range. And of course, yeah, making the range of the original, but then that becomes a domain of the inverse. Just making sure you're using square brackets, and you probably want to put like your little x as an element of in there. Sketching F inverse, label endpoints. Yeah, why not? Very briefly going to revise your ability to sketch a quadratic, a very simple quadratic. We'll call it a speed test then, see how fast you can get a quadratic down and get a free 2 marks. I guess you'd also need to do the intersection between F and the inverse, so that's slightly tougher than just sketching a quadratic, but not by too much. I guess, yeah, just let me know when you've got the graph done and then we can just sort of compare it to thing rather than you having to explain a picture of words.
Is the graph of the quadratic, is this going to be like starting from the origin and then in a quadratic sense it goes up to 2? Yeah, 1, 2.
Yep. So you basically would have created that. Yeah, it's going to peak at 2. The other thing I mentioned to do was the crossover point. Did you get that far?
Oh, no, not yet.
Cool. Okay. Well, you know what you're targeting. Let's see how we get there.
Is it a half and a half?
Half and a half is correct, yeah. A couple of ways you could have done that. How did you do it?
I was about to solve it, but then I thought I could have just seen where it intersects with y is equal to x, and then
Yeah.
done it that way.
Yeah, that's the better way of doing it. Um, so you're already beating me as far as back when I started. I decided to go the f equals f inverse route, and then obviously that's a bit more complicated. Still pretty quick to see um, where the solutions are going to be from that, but yeah, definitely tougher than if you had just made it equal x. Yeah, that's about it. You don't need that dotted line, by the way. It just says sketch the inverse endpoints point of intersection. That's pretty much it. This will be decent. Total area of the two regions. One is bound by f and f inverse. The other is also bound by f and f inverse, but this time there's also the line x equals 1 to, to cut it off. And then give your answer in a form. I believe this one wasn't so bad to get it to that form. Total area of regions bound by two separate curves. Fairly standard question. It'll be a fairly lengthy one, as you can probably imagine based on how many lines of working you have access to. Area bound by two functions is always going to be a top take bottom scenario. So you've got a picture that you can already look at based on your graph of the quadratic, and ideally you have it like in the real thing, you'd have it superimposed onto the square root graph. And so you can pretty quickly draw out, oh, yep, this one's above the other for this section. And then, yeah, your top take bottom with integrals. The challenge there is going to be in your ability to anti-diff and your ability to basically work with a lot of numbers all in one line. You don't have to do them all in one line. Feel free to split those up into two separate things and then solve them one at a time if it feels like it's easier to manage. got a drawing of what you're trying to find the area of, it would look basically something like this. You would be trying to find this section in here, and then this section here cut off by the line x equals 1. From there, you identify your top and bottom. So over the first section, black is above blue. Over the second section, blue is above black. So when you're doing your integrals, you do, well, exactly that. F take F inverse for the first one, from 0 to a half, and then half to 1 will be the opposite of that. From there, you'd want to make sure you anti-diff. So I've done my anti-diff a little bit strangely. That whole, there wasn't really a great syntax for doing it, you know, when you have like the upper or lower on the boundaries of square brackets. Basically the things inside the brackets, the anti-diffs here. So the anti-diff of this one is going to be that. Anti-diff of the right integral is going to be that one. So these are your two separate capital F of x's that you'd be working with. Whether you use the fractional index or the root, eventually you'd probably want to put it back into root form so it's easier to spot what you do. But just getting anti-diff, you're probably better off starting with fractional indexes and then converting afterwards. Then from there, you're just going to sub in your capital F of half, capital F of 0, capital F of 1s into all the spots that you need to. Remember, it's always the top integral bound first. So for the first integral, you do capital F of half minus capital F of 0. That's this set of... Actually, is it? Why have I got 3 brackets? Strange. Anyway, so this is your capital F of a half minus capital F of 0, yeah? Because that's the... If you sub in 0 into this, that whole thing will disappear. And then this is going to be your capital F of 1 minus capital F of a half. Got the 1 into those spots.
Chris, is the answer 1 on 6 units squared? Oh, no mind.
Nah, it's a little bit off. So I guess, you know, part of the hint there would be checking the give your answer in form of. Yeah, maybe did you maybe check anti-diffs first? Did you get those? Good.
Yeah, I see what I've done wrong. It's an addition error.
Oh, sure.
An
Yeah, okay.
addition calculation error, sort of.
Yeah. Yeah, no worries then. So anti-diffs are good. Subbing in was good. Just some sort of calculation issue.
Yeah.
Cool. Yeah, just for the recording, let's see. Is there anything in particular we could do? Well, you would shove in your values, sub in the easy zeros. Um, Keeping big brackets of things can help clarify your thinking a bit easier. Powers of half, any fractional indexes you can rewrite as roots. So that's fairly chill. What am I doing from here to here? Looks like nothing. I'm just rewriting the line. Oh wait, no, actually I've taken a negative out. Fair enough. And the reason I guess I've done that is because these two things now become the same. So I don't actually have to evaluate both of these individually. I can say, oh yeah, I just got two lots of that. And so I only have to simplify it once. And then, yeah, once you get to this stage, this is a lot more manageable. Probably not much else to say from there. Ended up with this one 5 minus 2 root 216. Well, you still are. Yeah, good. Awesome. Now, we're going to get through all of it? Nah, I got to question 8. Almost getting through the whole exam. Question 7. Quadratic point, show that P. That's a funny question. Show that P is not on the graph. Usually you get the opposite, which is show that P is on the graph. You still solve it basically the same way. They're not trying to trick you that hard. I'm curious what you guys try to do though to prove it's not on a graph.
Okay, so I subbed the point into the graph,
Yep.
into the graph to the equation, and left hand side was not equal to right hand side.
Yeah, that's a solid way of going about it. Sub in point, 0 does not equal 9, therefore P does not exist on the graph. Easy. Alright, here's a generic point that exists somewhere on the graph. Find the slope that connects P and Q. So remember P being the point 1, 0, and Q being somewhere on the graph of F. Generically figure out the slope between those 2 points. Slope between points can only really mean one, maybe two things.
I forgot the calculation thing, like the equation, but I don't know how to put into terms of A. I've got f of A minus 1 all over A.
F of A minus 1 all over A. I feel like you got things in a little bit of a different order. Did you rise over run?
Yeah.
Yeah, okay. Uh, 1, 0.
Oh, I
Yeah, 1 is
see.
an x value.
Oh, never mind.
Yeah,
So it should be f of A over A minus 1.
yeah, that's a bit better. I'm going to highlight that. What do you think we can do with that? That should help you expand out. there isn't really much else to be done after using f of x to expand out your f of a. Um, the only thing you might spot is a way to cancel out a common factor of a minus 1. But there is no common factor there. So you would just say, oh, yep, I got f of a on top. That's the same as just a squared plus 3a plus 5. And then you just leave it as that. Okay, got about 2 minutes. Can knock this one out. Slope of tangent to the graph of f at point Q. So Q is the thing that exists somewhere on f. Slope of tangent. Again, we only have very few methods of solving that, which is a good thing.
Is it 2a?
2a, 2a plus 3?
But is 3 like involved in the slope? Oh, it is. Never
Yeah,
mind.
because it's f dash a.
Right.
Because you do your f dash x, that gets you 2x plus 3, and at a, well then yeah, you're going to shove in your a into the x spot.
Okay, cool.
Sweet. Cool. And then triple I. I'll probably just talk. Oh, no, I'll pitch it, see if anyone has an idea first. Let tangent pass through point P. Find the values of A. So maybe you won't have an answer immediately. We'll just sort of talk conceptually about it for now. Consider, of course, you've got this I and II section. You've already got some information about the tangent of f at x equals a. Find the values of a. Any thoughts that are coming up immediately? Or shall I just run into it if you've got somewhere to be?
Is it going to be like subbing in the point P?
Something in the point P. Not particularly. Something in the point P you could only really do into F. It's going to do with the fact that you have two methods of creating gradient. You've got m equals this, you've got m equals that. Both of those have a's in them. This one's got an a in it, this one's got an a in it. They're both m. One is calculated through rise over run, and the other is calculated through f dash. And so you just sort of shove the two of them together and expand for a. That's all that's going on there. Sometimes you have to kill one. In this case, there was no restrictions on a. Yeah, not seeing any restrictions on a. So yeah, that's overall what's going on there. Using a bit of the context clues of the indents, so I, double I, and then into triple I, that's when you can start inferring that previous stuff becomes important. Cool. All right. If there's any further questions, I'm happy to answer them. Otherwise, enjoy the rest of your day.